Hey guys, so this is Caden, and man, was he a fun roller coaster to work with this summer. So unfortunately for him, he chose a pretty physically intensive project, which he'll explain in a second, and then even more unfortunate for him, he chose a project that required a lot of prototyping and a lot of tests. So most of the days are filled with groans, complaints about all the exercising he had to do. Um, something that became kind of infamous in our classroom was the Caden crash out. So if anyone in J7, can relate to that. But what kind of stood out the most about Caden was his persistence. Anytime a sensor failed, anytime his code wouldn't work, he'd keep grinding at it until it did. And that was really admirable. And he conquered all these challenges and now has an amazing project to demonstrate for you guys.
Okay, hi, I'm Caden, and I'm from Mission San Jose High School, and for my project, I chose the knee rehabilitation device. And so what this device essentially does, it's able to alert the user of whether or not they're doing a good or bad squat. And I chose this project because it relates to my journey as an athlete, and often when playing my sport, knee injuries are sustained. And I hope that this device will allow the rehabilitation process for users to be more efficient and more fun. And so here's a quick overview of how it works. So right now, since I'm behind this podium, you can't really see my project, so I projected on the whiteboard here. But there's an accelerometer located on the bottom right of the device, and there's a flex sensor behind the knee, which is around here. And essentially what these two sensors do is they send data to my code, which will process it through a series of if-else statements and decide whether or not the buzzer should buzz. And so on top of that, my base project, I've also added an LED light, and I'm hoping that this LED, which is right here, will help users with hearing disadvantages be able to also use the project and know whether or not doing a good or bad squat. So now I'll go into the project demonstration. So currently, as I'm standing up, nothing's really gonna happen. The lights are gonna be yellow. Okay, I'm sorry. But, so the lights are gonna be yellow, nothing's really gonna happen. I'm in an idle position, I'm standing up right now, so nothing's really happening here. And I'm gonna do two squats, a good and a bad squat for comparison, so you guys can see. So I'm gonna do a good squat right now. Obviously it's really hard because it's volume. But okay, it's fine. Okay, so I'll do a good squat. So you'll see right now as I'm bending down, the lights are red and the buzzer's buzzing. This is because I haven't fully reached the squat angle yet. And once I finally reach my squat, the lights will slowly fill out to be green. This will be a 1 second timer. It's supposed to be 1 second. I don't know why it's a little longer. But essentially it's a 1 second timer so the user can hold their squat for 1 second. And I'll do two bad squats. Okay? And you'll see that. And you'll see that while I'm doing these two squats, the lights are always red, the buzzer's always buzzing. And there's one common characteristic with these two squats, and that's the fact that my knees are either bent too inward or too outward. And with the accelerometer, which is right here, I'm able to detect the change in angle. And so what the accelerometer essentially does, it's able to detect rotational angle around 3 different axes, the X, Y, and Z axes. And these 3 values correspond to the terms pitch, yaw, and roll. And if you've ever rode an airplane, you'll know that pitch is when the nose of the airplane goes up and down, yaw is when the airplane goes side to side, and roll is when the airplane is banking left to right. And so after doing a little bit of data analysis and looking at my values for these three terms, I was able to figure out that the one value that differentiated a good and bad squat was yaw. And that's why I used in my code as thresholds. So I said if the yaw was greater than, 200 or something, then I'll tell my device to alert the user that they're doing a bad squat. And so obviously, since this is my first time creating circuits and writing code, I encountered numerous challenges and obstacles along my journey to finish my project. And so originally, when I was in my first milestone, what I had to do was retrieve data from both my flex sensor and my accelerometer. And to do that, I needed to create a circuit incorporating both the sensors and one resistor. And after doing some research, I mistakenly thought that I needed a 220 ohm resistor. But when I was building my circuit, I accidentally grabbed a 10K ohm resistor. But it only gets funnier from there, because after the next 2 weeks of testing, upgrading my design, I kept using a 10K ohm resistor, thinking it was a 220 ohm resistor, and it worked perfectly fine. And when the time came for me to finalize my project and solder everything together, that's when I used a 220 ohm resistor. And guess what? Of course nothing worked, right? So that's what lessons like these taught me to be a lot more patient with my circuit building, my code writing, and in general at Bootstrap, I've learned also to, be very patient with the engineering design process. And USEP also taught me and also led me to discover my true passion for engineering and circuit building. And in the future, I really hope to become either a mechanical or aerospace engineer and make a positive impact on the world. Thank you. Yeah.
So, lots of practical application for older athletes such as myself. You see this ever getting to a point where it's gonna be in a serious need race, and so if you're doing physical activity, playing golf or soccer, it will kind of tell you if if you're not doing it the right way, if your technique is not.
So you're saying I can apply this to an actual sport and see whether or not
Yeah.
the technique is right? I think that's definitely a good idea, and I think it's possible. Currently with like lots of machine learning, you can do algorithms and determine like whether or not your technique is good. And you can probably apply that sort of data onto like your accelerometer and your buzzer, and be able to determine whether or not you're actually doing a good like golf swing or soccer swing. I think that's a really smart idea though. I've never really thought about that. Yeah.